So probability is a very important chapter from the perspective of UPSC and DA. Let's start with the first question that we have that we were solving in a previous class. It's not a previous year question, but an important example. So here in this question, we can see that there is a box having 20 tickets like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 12. Like this, there are 20 tickets. 4 tickets are drawn one by one. Okay. After each draw, the ticket is replaced. You have drawn a ticket, then you have replaced the ticket. The probability that the largest value of tickets drawn is ticket drawn 15 is. So you're withdrawing 15 tickets. So the largest value of the ticket should be 15, or it is just not like that 15 can only come once because we are replacing it. So 15 can also come again, or any number less than 15 is also acceptable. So this is just a one possible scenario. I'm not saying that this is the desirable or favorable outcome. This is one of the favorable outcomes. We are withdrawing the conditions that the largest in this particular favorable event, 15 has to come at least once for sure, because the largest value of tickets drawn should be 15 at least. Okay. So is that clear that 15 should come at least once? Yes. So what is obvious for us? That event we will call it as P, that we want it for sure. Getting okay. Now, what is the probability of getting 15 as a ticket? So how many total tickets are there? 20. How many desirable? 15. We want 15 now. So there is a one only ticket with the number 15. Okay. So probability becomes 1 by 20. And this event is getting repeated 4 times. Like tickets are withdrawn 4 times. Okay. What is the other event? What is the other event other than the success that we wanted? Now here there's a very important thing to understand, that Q will not be equal to 1 minus P. Okay, you will understand it little time later. But first, listen to me what I'm saying now. See, all of the tickets that we are withdrawing has to be 15 or less than 15. They just cannot be 16, 17, 18, 19, 20. These scenarios are just not acceptable. Even in, they are just not acceptable. Okay. So what are the other events that can happen other than success? I'm not now see, there's a difference here. The opposite of success and the events that can be there other than success. Okay. So if 15 is there, there are 3 remaining tickets to be withdrawn. They can be any number, 15 or less than 15. Okay. So Q event is about withdrawing a ticket of number 15 or less than 15. Is that clear that Q is an event here about withdrawing a ticket of 15 or less than 15, and why it is so? Clear?
Yes, sir.
Now understand one thing, that Q is not equals to 1 minus P. Why? Because Because we are excluding the cases of getting 16, 17, 18, 19, 20 here. In the other event as well, in the first event as well. But in the total possible outcome, they are there. We have considered 20, right? In the denominator still. But we are excluding some outcomes as our favorable or unfavorable. So that's why Q is not equals to 1 minus P here. If that is clear, the question is very cakewalk now. It becomes a cake now. So we are aware about this probability distribution formula. So N, C, R. How many times do we want this success to happen? At least one time, na? So this makes us R is 1. Or at least one time. So we want success to happen one time. This P has to happen, has to occur one time. That makes R is equals to 1. Okay. P raised to power R into Q. What is Q here? Withdrawing 15 or less than 15. So how many favorable outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Total 20. So Q is 5 3 is 15, 5 4 is 20, 3 by 4. Raised to power n minus r. 4 minus 1, that is 3. Okay, let's solve it. 4C1 is 4 only. Into 1 by 20. Into 3 raised to power 3 is 27. 4 raised to power 3. 4 cancels 4. And nothing. 27 into, uh, 20 into 16. 320. This is our answer. Only thing to understand here was P and Q. What is P? What is Q? Okay. Now please reread the question and read particularly how and what is P and Q. 1 minute to read. Done?
Yes, sir.
P event is about getting 15 as the ticket number. And it should happen at least once. So we want it to happen one times for sure. A is the correct option. Yes, A option matches with our answer. See here. Consider the following statements related to a variable x having a binomial distribution bx with n and p. Binomial distribution. So p is half here. Probability of a success is half here. Then the distribution is symmetrical. Distribution is symmetrical. What is probability distribution we have considered earlier, right? So if p is half, then definitely the chances are 50%. So it's a symmetrical game, like head, tail, tail, head. They are symmetrical events, na? Head, head can also happen. Tail, tail can also happen. They are symmetrical events. One case of both heads, one case of both tails, one case of head and tail, one case of tail and head. That's how symmetry exists. So the probability is half, and distribution is, we can see that it is a symmetrical distribution. So first statement is correct. Now coming over to the second statement, that P remaining constant the probability distribution, that is NCR, P raised to R, Q raised to N minus R increases as N increases. Okay. So what is asked, that the probability distribution here, will increase or decrease when we will increase the number of trials. Okay. So we may understand it from the fact that let's take a scenario of tossing the coin as well, tossing the coin only. So if the coin is tossed once, total outcomes can be 2. If it is tossed twice, head head or head tail can come, tail head can come, tail tail can come. This is a sample space. Okay, and this is the sample space for a coin tossed, for 2 coin tossed. Now here probability of x is equals to r. So let's say the case when we are talking about number of heads. So here number of head is 1, number of head is 0, number of head is 2, number of head is 1, number of head is 1, number of head is 0. So here if we increase the trials, number of trials, the probability distribution also increased to 100, right? So second statement is also correct. Hence C becomes our answer. Let's check. Yes, it is the case. Any doubts, anyone?
No, sir.
Yeah, please remember, we have also talked about this example, same example while discussing probability distribution. Next question. Now, if you are wondering about these highlighters, so actually it's not just about the answers, it's also about important questions are highlighted with certain colors, because when I used to study for NDA, then I used to mark questions, important questions with highlight. So I have brought those specific previous year questions also only. I've not brought all the previous year questions, easy or tough. I have just brought important PYQs which have some different concept in them. Very good. Hmm. An experiment consists of flipping a coin and then flipping it a second time if head occurs. So first what we are doing, we are flipping a coin. So if a coin is flipped, there can be two outcomes, head or tail. Okay, then it is said then flipping it a second time if head occurs. If head has occurred, we will flip the coin again and their outcomes can be head or a tail. Okay. If a tail occurs on the first flip, then a six-faced die is tossed. Okay, if tail occurs, then a six-faced dice is rolled. If dice is there, how many outcomes can be there? One, two, three, four, five, and six. Okay. Assuming that the outcomes are equally likely. Okay. What we are assuming that all the outcomes are equally likely. So what are the all outcomes? First, let's try it. So outcome is here head and head. First outcome is head and head. The another outcome can be head and then a tail. Okay. Another outcome can be tail and then one on the dice. Tail and then two on the dice. Tail and one on the dice. Tail and or two on the dice. Or tail three on the dice. Tail 4, tail 5, tail 6. So these are all the outcomes of the event that it is happening here. It is given that we have to assume that all the outcomes are equally likely. What means? It means that they are all the sample points. In a sample space, all the sample points have equal possibility of occurring. So now we have to find out what is the probability of getting one head and one tail. So one head and one tail is here and no, nowhere else. Only one case is there out of eight sample points. So that becomes a probability of eight. Is that clear, everyone? Please reread the question. If it was not given that the outcomes are equally likely, we had to then solve this question with different manners by solving the probability of flipping a coin. Head has 1/2 probability, and then tail one have 1/6 probability. Two has a probability of 1/6 from an dice. Similarly, so on and so forth. But it is given here that all outcomes are equally likely, so it made our job easy. Is that clear, everyone? Please read the question again and do read it, okay? And then the outcomes. 1 minute or 30 seconds. Clear?
Yes, sir.
Cool. Events when a coin is flipped had this. Now, in an examination, there are three multiple choice questions. Oh, short exam. And each question has four choices. Okay. If a student randomly selects answer for all three questions, इस एग्जाम के लिए भी पढ़ के नहीं गया ना लाइक if a student randomly selects answer for all three questions, what is the probability that the student will not answer all three questions correctly? So Murphy's law, we have to find out him messing up badly. Anyways, we'll do it. It's a question. So there are three multiple choices. So every question has to be have some choice. Okay. So there are three multiple choice questions. Okay. Every question, student can fill four answers. So total number of cases, total number of ways in which a student can answer three multiple choice questions having four choices is 4 into 4 into 4 into 4 into 4 into 4, which is 4 raised to power 3, which is 16 into 4, which is there are 64 total number of ways to answer. So, um, how many correct answers will be there for a question from multiple choice question? There's only one correct answer. One correct answer for this also, one correct answer for this also. So how many ways to fill these three questions correctly? All correctly, one raised, that is one. Okay. So first let's find out that the probability of answering all correctly will be 1 by, that is the favorable number of way, and 1 by total number of cases that are possible. This is probability of answering all the questions correctly. But here we need to find out the probability of that he will not answer all three questions correctly. So it's just opposite we need to find out, right? So let's call this event of answering all the questions correctly as uh, as pass, as P. Okay, but what we need to find out is it's just opposite. So it will be 1 minus probability of event P. 1 minus 1 by 64 should be our answer. 64 LCM, 64 into 1, 64 minus 1, 63 by 64. Answer number B is the correct. Option B is the correct answer. See, we need to find out the number of ways in which he will not answer three questions correctly. So just opposite to that, answering all the questions correctly. So we have just find out the probability of answering all the questions correctly and then subtracted it from what? Clear?
Yes, sir.
Since probability of answering all three questions is 1 by 64. Probability of not answering all three questions correctly is 1 by 64. 1 minus 1 by 64. Probability of an event not happening is 1 minus probability of this event happening. So what event was happening was passing or like answering all correctly. So here this will be not answering them not correctly. Next question. Two letters are drawn from the word home. Okay, home. What is the probability that both the letters are vowels? Okay, we're withdrawing two letters. So two letters we want. How many choices do we have? How many, like we are discussing about total cases. How many choices? Four choices. How many choices for here? One is already withdrawn, so three are left. So these are 12. What about favorable? We have to withdraw only vowels. How many vowels are there? Okay, two letters has to be withdrawn. Two vowels are there. Two choices for here, one choice for here. Total number of favorable cases are two here. Probability of any event is number of favorable cases upon total possible. So 2 by 12 is 1 by 6. Clear?
Yes, sir.
So this is a theoretical question asked in UPSC and DA 2012 second paper. An event having no sample point is called an elementary event? No. Can anyone tell me what is a sample point? Gurucharan. Do you guys take notes?
Sir, do you want me to answer?
Yes. What is a sample point?
No, I thought you were asking Guru sir. Sir, it's the outcomes which are present. Like,
Yeah. Okay. Hmm. And what is
out-
the sample space?
sir, isn't the sample space is the group of sample points?
Yes.
So it's in
Right.
trials or outcomes.
Yes. Right. So an event having one sample point is called an elementary event. Yes. Any event having one sample point is an elementary event. An event having two sample points is called no. An event having many sample points is called an elementary event. No. Now, what is a simple event? What is a composite event? We are also going to talk about them in upcoming slides. Can anyone tell me what is an elementary matrix? What is a unitary matrix? Remember, please keep on revising your notes, okay? Any event having one 7 point is called an elementary. Next question. What is the most probable number of successes in 10 trials with probability of success 2 by 3? Now, this is a question which you can solve with common sense. And I would like both of you to give a try. So first, let's start with Yarini. Yarini, whatever step you will tell, I'll write that on the board, okay? On the screen. So start thinking. And after Yarini, next turn is of Guru. Okay? There are 10 trials with probability of success 2 by 3. Like there will be 2 successes in 3 trials. So how many number of attempts should we make?
10 attempts.
10 attempts. No, actually, attempts
Oi,
is not asked. It is given that we are making 10 attempts. You are right. But we have to like tell them that how many uh, how many like what is the most probable number of success? Like what is the number of maximum successes that can be occurred in 10 trials?
Sir, it's 7 attempts.
One trial have yes, Guru Charan.
7 attempts, sir.
Sorry,
It's 7 attempts, sir. Can you hear me, sir?
7.
Yes, sir.
Why 7? Explain. अक्कड़ पक्कड़ बम्बे वो नहीं करना. Think.
So it's 2 by 3 into 10. N is equal to
Okay, 2 by 3 into 10.
10.
Ah,
Will get us N is equal to 6.675.
yes. And also we can think it in this way that there are 2 successes in 3 trials. In one trial, there's 2 by 3 success. So in 10 trials, how many successes can be there? Same as Guru Charan said. 20 by 3, which is 6.6. So these many successes can be there. We have to tell the maximum. So 6 or 7. 6 is not in the option. We have to tell about the upper number, higher number. That's why 7. Clear? Very good, Guruji. Now here, if we see and go by the solution, then it is very strenuous, tedious. Next, a bag contains balls of 2 colors. There's a bag, 3 black and 3 white balls are there. What is the smallest number of balls which must be withdrawn from the bag without looking? So that among these three, there are 2 of the same colors. How many total balls do we have? 6 balls. Okay. If we withdraw 2 balls, okay, any 2 balls, as per the option A, so there will be 4 balls left. If we withdraw 2 black, so what will be the situation? 1 black and 1 three white, or two black and two white. But still, like, we have to have we have to have two bowls of the same color. Okay, so let's try to understand the question once again. There's a bag containing these two. There's a bag having two colors. Okay, three black and three white. Smallest number of balls which must be withdrawn from the bag, without looking, so that among these three, two of the same color remains. Among these three, two of the same colors. So that means if there has to be two balls left of same color, then we have to at least take four balls out. Why? Now understand here that there are three balls, three whites. If you withdraw four balls in any manner, let's say you take three black out and two white out. You have taken these balls out of, sorry, no, not three black and two ball. Let's do it. So what we actually are doing, we are segregating the sum of three, the sum of four on two places. Sum of four on two places. So it can be 1 plus 3, 2 plus 2, 3 plus 1. So let's call this black or so call this white. Okay, if that is happening, so these are the balls that we are withdrawing out. What will be left here? Two black balls and no white balls, and one black ball and one white ball, and zero black ball or two white balls. If we are withdrawing four balls, this is inside the bag. This is a case of inside the bag, and this is outside the bag that we are drawing. So, which must be drawn? So, among these, now we are talking about which balls? Can anyone tell me? Among these means drawn balls or the balls that are there inside left in the bag? See, understand the sentence, the question. What is the smallest number of balls which must be drawn? So we are talking about the balls which are drawn out. Okay. So here we are talking about the balls, not inside ones, but the outside ones. Here, if you see, there are balls of both of the colors, both of the colors, both of the colors. There's no zero because if we even if we have to take three balls out, then it can be of the same color. But if we have to take four balls out, then three has to be of one color and the one remaining has to be of other, because there are no other more balls of the same color. That's why we are withdrawing four minimum balls. Is that clear or should I repeat?
Sir, could you repeat it?
Okay. Let's bring the question again from here to here. Now, first, just read the question. There is a bag. So let me draw a bag. Black and white balls. So let's take two colors instead of black. Let's take red color. Give Okay, so this is one bowl, another bowl of same color, another bowl of same color. Okay, and we are also having three more bowls of different color of, let's say, green color. Instead of black and white, I'm just giving an example of different colors so that you like, because we cannot write black on black. Okay, so here, what is asked that what is the smallest number of balls we should take out of the bag without looking, so that among these, now this is a misprint. Okay, let me confirm, is this a misprint or not from the Google, but I'm very damn sure about the question. Yes, there is a misprint. Yes, there is a misprint. I was right. So instead of there is THER. THERE. This is not three. This is THERE. Now let's read the question. What is the smallest number of balls which must be drawn from the bag without looking, so that among these there are two of the same color? So whatever number of balls that we are withdrawing, they has to be uh, they has to have two colors. है ना? So what we all wish for is that there is a bowl of green and that there is a bowl of red. And how many minimum number of balls should we withdraw? Should we withdraw two balls? Let's start with the two scenario. If we withdraw two balls, then it may happen that one is green and another one is red. Okay, that's desirable. But it may also happen that both of the balls are green, which is not desirable. Both of the balls are red, which is also not desirable for us, because we need to find out a certain condition where it has to be in certain situation that it is a sure event that will get balls of two different colors. That among these there are two of the same color. But here there are no two balls of the same colors. In all note, there are no like sure scenario. This is also getting missed. This is also scenario or. So we are not sure about this event. Okay. If we withdraw three balls, then all three can be green or all three can be red. Okay. Desirable. We want two balls to be of the same color. But it may also happen that ZZR is there, RRG is there, or something else is there. Here, what is happening? That we are not getting balls of, see, from here we can understand. If we are withdrawing 4 balls, then after withdrawing 3 balls, it is for sure that we are going to get 2 colors. What we want is variety. Here, in 2 cases, we are not having the variety. When we withdraw 4 balls, let's say if we withdraw green, 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 then there has to be a red ball. Without red, the case cannot survive because we don't have more green balls. Otherwise, if we withdraw red, 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 there has to be a green ball. So in every case here, there will be balls of 2 colors. Okay. So for this, we'll have to take out 4 balls. Let me also give a different perspective, which can be more understandable. So if we withdraw 2 balls, so 2 balls, then actually what we are doing is we are withdrawing a green or a red ball, either. So I've changed the color red and green. Okay, so 2, 1 plus 1, or some can also become when 2, 0 is there or 0, 2 is there. So here in these 2 cases, there are no 2 balls of the same color. Like variety is not there. Green and red, both of them are not there simultaneously, which is not acceptable to us. When we are doing 3 balls, the sum can be written as 1, 2, 2, 1, or 0, 3, or 3, 0. Here, variety is not there in these 2 cases, which is not acceptable to us. Now, when we talk about withdrawing 4 balls, then green and red, we cannot start with withdrawing 4 green balls because they are not available only. So 3 and then 1 has to be written. And then 2 and 2. And then 1 and 3. Now 0 and 4 also cannot be written because there are no 4 red balls. So that's why here we'll have balls of 2 same color. Now see, now I'm talking about a different thing, variety here. But also understand one thing, that what is asked in the question. Among these, there are 2 balls of the same color. Here are 2 balls of the same color? No. Here are 2 balls of the same color. 2 balls of the same color. Available? Yes. Yes, available. But not all the cases, like there is a contingency where our event can become unsure. So that's why we cannot take a risk. That's why we are like withdrawing the maximum number of balls so that we can have the surety of that there will be 2 balls having same color. Here, 2 balls of having same color? Yes. There are 2 red balls of same color, 2 green balls of same color. But these are not desirable. Why? Like there are 2 number of balls of same color. So at least there has to be 4 balls withdrawn. So you can understand it from different perspectives. Minimum 4 balls have to be withdrawn so that among these there are 2 balls of the same color. Clear?
Yes, sir.
Next question. 2013. If 3 events A, B, C are mutually exclusive disjoint sets, then which one of the following is correct? I want one of you to give the answer. Can anyone explain what are mutually exclusive events after seeing the answer? Just tell me, if there are three circles I'm withdrawing A, B, C, how should I draw them for mutually exclusive? Should I draw them close?
Separately, sir.
Yes, separately. Because they are exclusive, they are disjoint sets like these. They will not have anything in common. These are mutually exclusive events which do not have anything in common. So if they do not have anything in common, so this is event A, B, C. So event A, B, and C will not be happening simultaneously. They are not happening simultaneously. The probability of such an event is 0. Clear?
Yes, sir.
Exhaustive events. If A and B are exhaustive events, then their union is their sample space. What exhaustive events means that those events are covering all of the universal set. So if this is the universal set, so then exhaustive sets will be written such a manner. This can be A set, this can be B set. These two events are covering whole of the universal set. Okay. So exhaustive means this only, that you are exhausting all the possibilities with these events. Like if a coin is tossed, so there are three events that can happen, like in reality: head, tail, or the coin may stand still, like straight. There's no other possibility or event that can happen. So the combination of all those three events are exhaustive. They are containing all of the possibilities. But the point that I just mentioned, that the point will stand is not mathematically considerable. Okay. So here this statement is correct because A and B are exhaustive. So their union set is their sample space. What it is trying to say, A union B is universal set, which is this. If A and B are exhaustive events, then their intersection must be an empty set. No, this is not correct. If I say universal set is this, and if I write A event as 1, 2, 3, B event as 3, 4, and 5, then A union B is equals to universal set. Yes, it is correct. And hence, it is both of these events are exhaustive events. But here, there is an intersection element. What is that element? A intersection B. What is A intersection B here?
1, 2, 3, 4, 5.
No,
So that's
that's
union,
union.
sorry.
That's the combination.
3 is intersection.
Yes, yes, yes. So this is not an empty event. This is not an empty event. So this is not always true. This is the correct answer. Clear?
Yes, sir.
The definition is very important. Now let's study about simple event. Simple event. An event that has a single point of the sample space. is known as a simple event. Like, it's very simple. It's very obvious. It's if I talk about some example, let's take an example if there's any example. There's no example given from real life. Let me think for it. Actually, in real life, there's no such event when only one contingency is there. But if I say like if I press the power button of my laptop, the single event that is there possible is the blackout of my screen. There's a single possible event, and if that becomes my favorable event as well, then it is a simple event. There's no complexity about it. So simple event is that event that it has only one event in its sample space. One. That if I press the power button of my laptop, the screen goes blank. That's the simple outcome. Only one outcome. So that's a simple event. Okay. An event that has a single point of the sample space is known as a simple event in probability. Is that clear?
Yes, sir.
The probability of an event occurring is this. This is the formula. There's nothing related to simple event. For example, the probability of getting a 3 when a 3 dies is toss. So this is just the formula of probability. This is not related to simple event. Now let's talk about compounding. If an event has more than one sample point, it is termed as a compound event, like tossing a coin, throwing a dice. The compound events are a little more complex than simple events. Of course, they are. These events involve the probability of more than one event occurring together. The total probability of all the outcomes of a compound event is equal to 1. This is very important. This statement, the probability the total probability of all the outcomes of compound event is equal to 1. This is really important. A really important statement. To calculate the probability, formula is used number of, okay, same stuff. First, we find out the probability of each event. Okay, anyways, this is important. These are the two things considerably reading. Need to be read. There's a total probability of all the outcomes of a compound event is equal to 1. Because we have listed all the sample points in the sample space. Is that clear? Yes.
Yes, sir.
Now comes the question. I want you to answer it. Guru Charan and Yad. These are the events A, B, C, D, E of the sample space. Sample spaces. Let me change the color. All the integers from 10, including 10, and between 20 and also including 20. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. How many elements are there in the sample space? Can anyone tell me quickly? There are 11,
Okay.
10 to 20, right? So A is the set of all even numbers. Okay, even numbers, so 10, 12, 14, 16, 18, and 20. B is the set of all prime numbers. Is 10 a prime number? What is a prime number? Anyone?
Which has only two factors.
Multiple.
Good, good. So, how many prime numbers are there? 11 a prime number, 13 a prime number, 15 a prime number, or no?
No, no, sir.
17 is a prime number, 19 is a prime number. Very good. So 11, 13, 17, and 19. Four prime numbers are. Okay, nice. C is a set having only one element, that is 15. D is a set having set of all integers that are equal or less than 16. So 10, 11, 12, 13, 14, 15, including 16. Event E. Event E is a set of all double-digit numbers expressible as a power of 2. Okay. So 2 raised to power 1, that is 2, 4, 8, and 16. Okay. So 2 raised to power 4 is 16. That's a that's a double-digit number expressible as 2 raised to power 4. And nothing else is there. So E has only single element, as in my perspective. Am I correct?
Yes, sir.
So in the first question, I sold everything for you, literally. You have to tell that. Also, let me explain once again. Mutually exclusive events are those which do not have anything in common. And exhaustive events are those events whose union are equal to the sample space. Okay. So their union are equal to sample space and their intersection is empty, mutually exclusive. Now tell me, an elementary events we have just discussed having one sample point in the sample space in their particular events. If there is one sample point, and about compound events, that there are more than one sample points. Now start with the 113th question, and you also have to tell me the reason. Who will go first? Who will go first? I have just explained mutually exclusive and exhaustive. In exhaustive events, those events, union has to become the sample space. And for exclusive, mutually exclusive, their intersection has to be uh, empty. Then they can be said as mutually exclusive. Okay, let me solve the first question for you. ABD, we are talking about ABD. Okay. Let's talk about the common elements in ABD. Are there any common elements in AB? No.
Yes, sir. No, no,
Are there
sir.
any common? No.
No, sir.
So if there is nothing common in AB, so definitely there is nothing common in ABD. Okay, so mutually exclusive. Yes, done. ME, done. Exhaustive ABD. So do 10 is coming? Yes, 10 is coming. 11 is, we are talking about A, B, and D. 10 is coming? Yes. 11 is coming? Yes. 10, 11. Okay. We are talking about union of ABD. So if it is there in one of the sets also, it's workable for us. Fine. 10, 11, 12, 13, 14, 15. Yes. 16. Yes. 17. Yes. 18. Yes. 19. Yes. 20. Yes. So all the elements from 10 to 20 are there. So the union of all ABD is equal to the sample space. So yes, they are also exhaustive. So mutually exclusive but not exhaustive events? No. Incorrect? No. They are also mutually exclusive? Yes, mutually exclusive and exhaustive. Event C is the correct answer. I'll not show you the answers now. First, now tell me the answers remaining. Is this clear? Is the 113th question clear? Should I explain something? Please ask. Should I repeat?
Yes, sir. Could you repeat it?
Yes. So what we are talking about ABD. First, we'll talk about the intersection of all, and it has to be phi for ABD to be known as mutually exclusive. Now, what are those elements which are common in all ABD? 10 is common in all? No, 10 is not there in B. 12 is common in all? No, 12 is not there in B. 14 is common in all? No, 14 is not. So let's just see on the smallest set. 11 is common? No, 11 is not there in the first set. 13? No, no, it's not there in the first. 17? No, 19? No. So there's nothing common in all three sets. Yeah? Those particular elements has to be common in all three sets. That is not so. We may say that ABD intersection is 5. Is that clear till now that how ABD sets have ABD events has become mutually exclusive?
Yes, sir.
Okay. Let's now talk about the exhaustiveness for them. So for them to become exhaustive, their union set has to become equal to the sample space. Now let's take the union of all, starting from the least number, 10. Then what is there? 11 can be written, and then 12 is can be written. Then 13 can be written from B set, or 14 can be written from A or D set. We'll not repeat elements, okay? In sets, we do not repeat elements. And order also doesn't matter. 15, then what else can be written? Yes. What else? Yeah, 15 from the D set can be written. Then 16 from the D set or A set. Then 17 from the B set. Then 18 from the A set. 19 from the B sets. 20 from the A set. Nothing else. Is this equal to sample space? A union B union D? Sample space is this. Is the sample space is equal to A union B union D? Are all the elements equal? Yes or no? It's simple question. You can answer it straight away. Yes, it is. All the elements are there of sample space in the union set. Yes. So if it is so, then we may call it that these events collectively are exhaustive. So if they are exhaustive and mutually exclusive both, then C is the correct option. Clear?
Yes, sir.
Yes. Now please tell me about 114th question.
Sir, option C.
Yeah. 1 minute. Yes. So A, B, C. A, B, and C. If we take common in all of them, there's nothing common. So they are mutually exclusive. Yes, it is for sure that A, B, C are mutually exclusive. Okay. If we take the union of all, then 10 is there, 11 is there, 12 is there, 13 is there, 14 is there, 15 is there, 16, 17, 18, 19, 20. Yes. They also have all the elements, their union set is equal to the sample space. Yes. So that makes them an exhaustive event. So C is the correct option. Yes. What about 115? B
Option
and C.
A, sir.
Okay, let me check. B and C, yes, they are not mutually, they are mutually exclusive because they do not have anything in common. So they are mutually exclusive for sure. Now let's talk about their union set 11, 13, 15, 17, 19 is not equal to the sample space. So they are not exhaustive events. A option is correct. But if we go and find out that compound events, no. B and C, for being compound events, they has to have all the sample points, means uh, B and C should be exhaustive events to be compound event. So that's not the case. Okay. So that's why this option is incorrect, not suitable for us. Definitely, they are not exhaustive events. So this is also incorrect. C and D is not because there are more than one sample points. Clear? 115th question. Great. 116. Guru Charan, please tell me about 116 if you are still awake.
Sir,
Option A, sir.
See, there is nothing common in them. So they are mutually exclusive for sure. Okay. About them, what is their exhaustive events? No, definitely they are not exhaustive. So option number B is ruled out. And option number C is also ruled out. Mutually exclusive, yes, they are. Are they elementary events? C and D? Are
Yes.
they elementary events or not? Yes, they are. So D is the correct answer. Okay. What should be our answers? C, C, A, D. C, C, okay. C, A, D. Okay. The first event, the first 113th, it's not given as mutually exclusive. Let's check whether it is mutually exclusive or not. So they have not considered A, B, D as phi. So why? So because they wanted all of the sets to be disjoint. And what we have done in the checking is that we were discussing about the most common part, but they didn't even wanted two sets to intersect. But in this case, in the ABD, there were few intersection like of 10, 12, 14, and 16 with set A. So that's why they have considered it as a not mutually exclusive. So B option becomes the correct answer. So I was incorrect while solving the question. Okay, is this clear that Y is the correct option, not A? Why B is the correct option of 1 and 13th? Should I repeat?
No, sir.
Because A intersection B intersection D is definitely phi only, but they wanted that A intersection B should also be phi. B intersection D should also be phi. A intersection D should also be phi. That's the reason. Okay, let's now move ahead with our upcoming questions with the letter speed. If mean and variance, so we know mean was NP and variance is NPQ. If mean of variance of a binomial variate x are 2 and 1 respectively, then the probability x takes a value greater than 1 is. Okay. So what is x probability? X is NCR P raised to power R Q raised to power N minus R. First, let's find out Q by dividing the equation 1 by equation 2. Dividing equation 1 by 2 makes it Q is equals to half. If Q is half, P is 1 minus Q. That is also 1 minus 2. Okay. What is N then? If P is half is equals to 2, then N becomes 4. Okay. So X is NC4. P is half raised to power R, which is this, N minus 4, 2 raised to power N minus 4. NC4, 1 by 2 raised to power 4 plus N minus 4 becomes N. So that is X. And now what matters is, sorry, one mistake I have done. N is equals to 4. R is unknown to us. 4CR, half raised to power R. Q is also half. N minus R. 4 minus R plus R. 4CR, half raised to power 4. That's the value of X. So X is 4CR, half raised to power 4. What do we have to find out? The probability that X takes a value greater than 1. So X has to be greater than 1. Okay. So for what value of R takes a value? The probability that X takes a value greater than 1. Okay. So how many, like, if we are writing 4CR, how many values of R can be there? How many values of R can be there? 0, 1, 2, 3, 4, not greater than 4. Okay. So what we have to find out that the probability of X taking a value greater than 1. Okay. So these are the total cases. Let's find out the favorable ones. So 1 by 2 raised to power 4 into 4 C of 0. That becomes 1 by 2 raised to power 4. 4 C of 0 is 4 factorial divided by 4 minus 0 factorial into 0 factorial. That is basically 1. So 1 by 2 raised to power 4 is what? 16. 1 by 16 into 4C1. 4C1 is definitely 4 by 16. This is 1 by 4, which is also not. This R is equals to 0. Here R is equals to 1, which is also not greater than 1. Let's take R value as 2. 4C2 divided by 16. 4C2 is 6 and 6 by 16 is 3 by 8. R is equals to 3. 4C3 divided by 16. 4C3 is 4 only. That is also 1 by 4. So 4R is equals to 4. 4C4 is also, let's say 4C4. अरे कहाँ आ गए? So R is equals to 4. Let's take 4C4 and divided by 16 as 4C4 is 4 factorial divided by 0 factorial into 4 factorial divided by 16 becomes 1 by 16. What we had to find out actually, that the probability of x takes a value greater than 1. Okay. X takes a value greater than 1. Greater than 1 means 2, 3, 4. So 3 by 8. So greater than 1, r is equals to 2, 3 by 8, 1 by 4, and 1 by 16. 3 by 8, 1 by 4 plus 1 by 16. These are the probabilities that we have to consider when r is taking more than 1. Taking LCM 16, 8 2s are 8 2s are 16, so 3 2s are 6, 4 4s are 16, so 1 into 4, 16 plus 1, 6, 4, 10, 10, 1, 11 by 16 is our answer, which is given also. Now, we have solved this question from a typical way, from a tedious and strenuous way. First, let me ask this, is this method clear? Are there any questions? If there are any, please ask.
No, sir.
What we have done here, it was given, we know that mean is this, NP, variance is this. Using this, we find out the probability of failure. Then we find out the probability of success. We also find out the number of trials. What we had, N, P, and Q. And we know R is missing. And N was 4, P was half, Q is also half. And R can be, if like N is 4, R can be 0, 1, 2, 3, 4. It was given to us that we needed to find out the probability when R was taking value of greater than 1. So R was taking 2 or 3 or 4. So we'll find out the probability of 2, 3, 4. We'll add them. So this is what we have done. How we can find out X of R, 4C of R, 1 by 2 raised to power 4 raised to power r into 4 minus r, that makes it 4 only. So here, instead of so answer can be given by x taking more than one value. In this method also we can find the answer, but there's a more efficient method. By just finding out x is equals to 0 and x is equals to 1, and then subtracting it from 1. This is also give us the same answer as of this probability of event E, probability of event E here also. Is that clear? We have talked about this concept in the very starting of the probability chapter, where we were discussing about at least one and at most one or two. Clear?
Yes, sir.
So we have find it out using method in earlier. Let's now find it out using this method. So 1 minus x is equals to 0, 4c0 divided by 2 raised to power 4, that is 16, plus x is equals to 1, 4c1 divided by 16. Okay. So 1 minus 4c0 is 4c1 0 is 1 by 16 plus 4c1 is 4 by 16. Taking 16 as LCM, 16 minus 1 plus 4 is 5. 16 minus 5 is 11 by 16. This is way more easier than finding out this. Clear?
Yes, sir.
A certain type of missile hits the target with the probability of 0.3. what is the least number of missiles should be fired so that there is at least an 80% probability that the target is hit. Okay, so what is the least number of missiles should be fired so that there is at least an 80% probability that the target is hit. Earlier, there was also a similar kind of question, 2 by 3 success, 10 attempts, and we had to find out that how many chances are there, how many attempts should we make so that we make sure the event is a sure event. But this time, we are not discussing about the event being sure. We are discussing about the event being 80% probable. So that changes the game. Yes, Guru Sir. And 2016 paper of ND was the toughest. But we are going to solve it using a simple method. So let's say there are chances of hitting a missile in the first event by 3 by 10. So let's call the event of hitting a missile a target by event H, or for missing it, let's call it event M, which is 1 minus 3 by 10, which is 10 minus 3 by 10, 7 by 10 is the chances. There are 70% chances that the missile will not hit the target. Okay. So if we have to hit on a target, so our missile need to hit once only. If once contact is established, then the target is done. So in any number of attacks or trials, or then any number of n missiles that are going to get launched, only one contact is needed. Once that one contact is made, our job is done. Right? Do you agree? Like, we have to find out the discussing about the at least one hit. Okay. So we have discussed in earlier multiple times that whenever we discuss about at least one hit, just then subtract it from probability of getting no hit. At least one hit out of how many trials? We don't know. Out of n trials, and we have to find out those n trials. And we have to subtract the probability of getting no hit out of n trials. Is this thing making sense? We have done it earlier also, that whenever we had to find out the probability of an event getting done at least once. So, so instead of that, we just considered what is there before one. That is the event happening 0 number of times. So we'll take that in consideration and we'll subtract it from 1. Is that clear, everyone?
Yes, sir.
Okay. Now this is a very interesting question. So this is the probability of at least one hit out of n trials. So this has to become 80% as per the question. Okay, 80%. So 80% is what? 80%. That is 0 point. 1 minus probability of getting no hit out of n trials. So probability of getting one hit in one trial is 3 by 10. And in n trials is 3 by 10 raised to power n. Any doubts? No. Sorry. Miss is m. So 7 by 10 raised to 1. Any doubts?
No, sir.
For a miss, it is 7 by 10. For n number of miss, it is 7 by 10. For n number of simultaneous misses. Okay. Okay, let's go ahead then. So let's bring 7 by 10 raised to power n on the left hand side and 1 minus 0.8 on the right hand side. So this question 7 by 10 is 0.7 raised to power n is raised to power 1 minus 0.8, which eventually becomes 0.2. Yes, yes. So instead of getting into logarithm, let's hit and try, because we have to find out n value in number na in integer. So if you find out 0.7 raised to power 2, that becomes 49, and 0.49, which is not 0.2. Okay, and also one more thing. The 0.8 is the at least probability. It should be more than 80 or 80. So instead of writing equality sign, we should be considering the at least situation. Okay. So is 0.49 greater than 0.2? 7 into 7, and then yes, it is greater than 2. I'm thinking that I'm making a mistake. Let's read it again. What is the least number of missiles should be fired that there is an at least probability of 80%? So now what is the probability here? 80% should be the least. So where the equality sign will be made here? If 80% is the least, then 80% or more than 80%, right? It should be like that only, no? What should be the greater one? That should be the greater one. If 80 is the at least. So the greater sign should be on the other hand. Clear? And we know of all the numbers less than 1, if we increase their power, their value is going to decrease. Okay, let's increase their power. 0.7 raised to power cube is, I guess, somewhat 343, and point after 30, so 0.34. Is 0.343 less than 0.2 or equal to 0.2? No, but it is still less than 0.7 square. So let's move forward. 0.7 raised to our 4. Okay. So 7 into 3 becomes 7 3 is 21, carries 2. 7 4 is 28. 28 into 30, 3 carries, 7 3 is okay, 2 4. 0 after 4 digits. So 0.2401 is less than equal to 0.2000. No. We have to move forward with one more digit. Without finding, I can say n is equals to 5. Because we are realizing that we have come very close. We are just approaching. But still, let's find out. 7 into 0, 1, 7. 7 4 is 28. 2 carry, 7 2 is 16. Okay. And 0 after 5 digits. 1.6. No. It cannot happen like that. So 0 after 5. 3 and then 2 should be there, but I am very sure that we are doing a mistake. 7 into 1, okay, 7 into 4, 8, 2 carries, 7 into, there should be 1 6 1. So 0 point will be written here. Yes, 0.16807 is less than 0.2000. So here the condition satisfied, and we have to fire at least 5 missiles to hit it with 80% accuracy. 5 missiles. Whatever, yes, it's the correct answer. Whatever is there after this is just numerical portion, and you also have to be good at it. You have to understand that how should I go about it, because n has to be natural number for sure. Hit and try, hit and try, and we should not have a hit and try for 4 or 3 as we have done it, because it's not even there in the options. We should have started with 5 and we would have saved most of our time. So is the question clear, or should I repeat? Should I repeat the calculation part or the concept part? I know it's complicated one because it's the question of 2016 paper, the hardest mathematics paper in the history of UPSC ND. Is everything clear?
Yes, sir.
I'm going to ask questions if that is so. Now, please tell me that why we have considered the probability of hitting like the event of hitting the missile, the object, only at least once. Why we have referred it like that? Because boom boom happens only once, not again and again. Once the missile has hit the target, job done. So we have to just hit the target at least once. That's why. Yes. And see. There's one thing to understand. This is equal only. This is equal only. And this is the condition. This is the given condition. So this whole is less than equal to 0.8. And instead of this, I have written the right hand side. Clear?
Yes, sir.
Good. A committee of 2 persons is constituted from 2 men and 2 women. 2 men and 2 women. 2 places to be filled. What is the probability that the committee will have only women? First, let's consider all of the scenarios that are there. So 2 choices for the first position and 4 choices for the first position and 3 choices for the second position. How many total cases? 12 total cases. How many favorable? Favorable having only women. So if you want to have only women, so 2 choices for the first position, 1 choice is left for the second position. These are the favorable count. So the total number of, so the probability of this event should be 2 by 12. The answer should be 1 by 6. Let us see the answer. Yes, A is the correct option. It's wrong. The highlighted part is wrong. A is the correct option as per the solution given also. Okay? Clear? Crystal clear?
Yes.
Great. What is the probability that at least 2 persons out of a group of 3 persons were born in same month? Disregard of year. So, a person can be born in any one of the month. Okay, and we have to find out that there is a group of 3 persons. Okay, should I give this in homework or should I explain this? Your choice.
Anything, sir, your wish.
Okay, it's your homework then. Take a snapshot.
Okay, sir. One.
Like, let me see how many questions are left. We can.
Yeah, sir.
We have to discuss them tomorrow. Otherwise, if 2-3 questions were left, then I could have given them in your homework. Okay, we'll discuss them tomorrow also. Okay.
Okay, sir.
Okay. Thank you.